Dear students, welcome back to Chem Aspire. In this lecture class, we are going to discuss about the pi molecular orbital diagram of benzene. Let's get started. We know the molecular formula of benzene is C6H6, and this is a cyclic compound and having alternate double and single bond. We are having alternate double and single bond, double bond, single bond, double bond, single bond and double bond. And we know the pi electrons of this benzene are in continuous delocalization. They are in continuous delocalization. You know, the bonds can continuously delocalize and they are in the resonance. Now, each of these carbon atom of benzene is sp2 hybridized. Each carbon atom is sp2 hybridized, and each sp2 hybridized carbon atom is having one unhybridized p orbital. Each sp2 hybridized carbon atom is having one unhybridized p orbital, and therefore we have 6 unhybridized p orbital in benzene. And in a pi molecular system, the number of pi orbital formed is equal to the number of unhybridized p orbital. Since we have 6 unhybridized p orbital in benzene, we expect 6 pi molecular orbitals. Out of these 6 pi molecular orbitals, 3 molecular orbitals are bonding orbitals and 3 are anti-bonding molecular orbitals. So in benzene molecule, we expect 6 molecular orbitals, out of which 3 are bonding and 3 are anti-bonding. The 3 bonding molecular orbitals are represented as pi 1, pi 2 and pi 3, and the anti-bonding orbitals are represented as pi star 4, pi star 5 and pi star 6. Let us visualize the molecular orbital diagram of benzene. So we have to draw the 6 pi molecular orbitals of benzene. So let us know how many bonding interactions are there, how many anti-bonding interactions are there in the molecule. So this is pi 1 is the lowest, it is the lowest occupied molecular orbital. So we have 6 electrons, so 2 electrons are occupied in this pi 1 molecular orbital, and here the number of node is equal to 0. What is meant by node? Node is the place where there is no availability of the electrons. So here there is no availability of electrons, there is no node in this observed in this pi 1 molecular orbital. Now let us know how many bonding interactions are there. Since there are no nodes, all the orbitals they lie in the same plane, and there is an interaction. There is an interaction between C1 and C2, there is an interaction between C2 and C3, and there is an interaction between C4 and C5, and interaction between C5 and C6. Right? So these are the lobes which are getting interacted. See, this is where C1, C2, C3, C4, C5 and C6. So here you can say there is an interaction between this C1 and C2, interaction between C2 and C3, interaction between C3 and C4, C4 and C5, C5 and C6, C6 and C1, right? So here we can say there are 6 bonding interaction, 1, 2, 3, 4, 5 and 6. So number of bonding interaction is equal to 6, and there are no anti-bonding interaction. There is no anti-bonding interaction between the lobes of opposite signs. There is no interaction between the lobes of opposite sign. So anti-bonding interaction is equal to number of anti-bonding interaction is equal to 0. So pi 1 is the lowest occupied molecular orbital. It is having the lowest energy. There is number of node is equal to 0 and number of bonding interaction is equal to 6. Now the next occupied molecular orbital is pi 2 and pi 3. These pi 2 and pi 3 orbitals are called as the degenerate orbitals. What is meant by degenerate? Degenerate means having the same energy. These pi 2 and pi 3 orbitals are having the same energy. Here we are considering that there is a single node existing in the orbital. So this single node can pass through the bond. You can have a single node that is passing through the bond, or you can have the bond that is passing through the orbital, right? So now let us calculate how many bonding interactions are there and how many anti-bonding interactions are there. So coming over here, node is equal to number of node is equal to 1. Number of node is equal to 1, and now we have to draw the bonding and anti-bonding interaction, right? Say here you have a node, therefore this is a sign, this is a lobe of positive sign, so you cannot have an interaction here, you have to draw the positive lobe here only. There is no node here, so these two can interact, so the positive lobes will be like this. There is no node here, so you can have the positive node here, and since there is a node here, then you have to have the positive node here, and since there is no node here, then you have to shade like this. So let us know how many bonding interactions are there. Here there is one bonding interaction, there is one bonding interaction, 2, 3 and 4. There are 4 bonding interaction, you can say 1, 2, 3 and 4, where we do not have any nodes in between these bonding interactions. So number of bonding interaction is equal to 4, and obviously you have 2 anti-bonding interactions, right? So the bonding, there is anti-bonding interaction that may exist like this, and there is one anti-bonding interaction between the lobes of opposite signs. So anti-bonding interaction is equal to 2. Here when the node is passing through the bond, number of node is equal to 1. When it is passing through the bond, bonding interaction is equal to 4 and anti-bonding interaction is equal to 2. Coming over here, so there are 2 electrons which are occupied in pi 2. So coming over here where the node is passing through the orbital, right? So there is no node existing here, so you can have the interaction like this, and there is no node existing here, so you can have the interaction like this, right? So bonding interaction is equal to, so since there is no node here, bonding interaction, since there is no node here, there is a anti-bonding interaction, there is a bonding interaction. So here also you can say there are 3 bonding interactions. There are bonding interaction is equal to 4, and obviously anti-bonding interaction is equal to 2 across the lobes, across the node. There are 2 anti-bonding interaction, that is 2 anti-bonding interaction like this, there is a 2 anti-bonding interaction. So pi 2 and pi 3 are the next highest occupied molecular orbital, and we have node 1 in both the cases. They are the degenerate orbitals, and bonding interaction is equal to 4 and anti-bonding interaction is equal to 2 in this case. Now coming to pi star 4 and pi star 5, these are also degenerate orbitals, and these are the unoccupied molecular orbitals, or they are the anti-bonding, we call it as the anti-bonding molecular orbitals. Now here in this case, number of node, here in this case we are considering number of node is equal to 2. Number of node is equal to 2. So since there is a node here, so the positive lobe is here, so we cannot shade it here, so it is there. There is no node here, so we are drawing it here. There is no node here. So bonding interaction is equal to 2. Bonding interaction is equal to 2. Anti-bonding interaction is equal to 4. Anti-bonding interaction is equal to 4, because this is one bonding interaction, one anti-bonding interaction, one anti-bonding interaction and one anti-bonding interaction. Therefore there are 4 anti-bonding interactions in this pi star 4 molecular orbital. Coming over here for pi star 5 molecular orbital, so we are having 2 nodes which is crossing the molecule like this. So let us see how many bonding interactions are there. There is no in between, node in between. So there is a bonding interaction, and here also there is no node in between, so we have a bonding interaction, right? So we have two bonding interactions. So coming to anti-bonding interaction, since we have drawn up, this should be low. Since this is low, this is up, and this is up, and this is up, and this should be low, right? So we have number of node is equal to, again 2 here, bonding interaction is equal to 2, and anti-bonding interaction is equal to 4, right? In both the cases, pi star 4 and pi star 5, the number of bonding interaction is equal to 2 and anti-bonding interaction is equal to 4. Now coming to the pi star 6, that is the highest unoccupied molecular orbital, anti-bonding molecular orbital. So the molecule is divided into 3. We have 3 nodes in this molecule. There are number of node is equal to 3. Number of node is equal to 3, and therefore since there are nodes, 3 nodes in between, so no bonding interaction is happening. No bonding interaction. Since there is a node here, so you have to draw here lower. Since there is a node here, you have to draw it upper. So it is a node here, you have to draw it lower. Since there is a node here, draw it in the shade in the upper side. Then there is a node, you shade it in the lower one. So you can see that there is a no interaction between any of these orbitals, and therefore bonding interaction is equal to 0 and anti-bonding interaction is equal to 6. So pi star 6 is called as the anti-bonding highest unoccupied anti-bonding molecular orbital. So in this class we have seen that pi molecular orbital diagram of benzene. So in the pi molecule we have 6 pi molecular orbitals in the benzene ring, and out of these 6 pi molecular orbitals, 3 are bonding and 3 are anti-bonding, and we have found out how many bonding interactions are there in the and anti-bonding interactions are there in the bonding molecular orbitals, and how many bonding interactions and anti-bonding interactions in the anti-bonding molecular orbital.